Well, hi everyone. I just want to quickly show you the implementation of neural network from scratch. I have used Python and NumPy for implementing this from the scratch. NumPy for vectorization and broadcasting, as to we need to get over through the loops to we need to getting rid of the loops to compute the entire training set at the same time using vectorization that NumPy provides. So I've used NumPy. Other than that, I've used no other library to implement this neural network. So initialization, linear layer activation, softmax, then dropout, everything is being implemented from scratch. This is neuron, forward propagation, then binary cross entropy, L2 regularization, then computing the cost, then cross entropy for the multi-class classification, then linear backward, then activation backward, dropout backward, then activation linear backward, then this is the backward propagation loop or the method. And once you calculate the gradients, you need to update it. So update and then train method. Then this is test method and then predict. So everything I've implemented from scratch. So uh, that's it. This is the implementation of neural network. Actually it is a feed forward neural network. And what I did with this is that I trained MNIST handwritten digit classification, that is multi-class classification. So we have this data from 0 to 9 digits, that is handwritten digits, and we need to classify from which class it belongs to. So I passed this data to this neural network implementation and trained the model. So here are a couple of my observation from my learning. So this first I trained the model with this setting: learning rate 0.001, epochs 300, and there is no mini batch. I trained on the entire data set, like although I have splitted the data, but there is no mini batch. It's okay. Then next, for the first, without normalization and without dropout, I got 0.31 train loss and 2.80 test loss. As you can see clearly here, the gap between validation or test loss and train loss is very high. So that's why there is worst performance. Then, as I've already implemented dropout, so I turned on this dropout flag, and then we reduced our test loss to 1.37 from 2.80, right? Again, you can see the gap between two train and test loss is very low now as compared to previous one, but still we have some gap over here. So what I did next is I applied a normalization to the input layer. So basically I normalize the input, these images, by 255, as this is black and white image, grayscale image. So I normalized it with 255, and then you can see the train and test loss gap is very low, and you can also see the performance over here. So we reduced furthermore to 0.41 test loss, and train loss is 0.36. And one more thing that you can notice is that the learning rate is also very high as compared to the previous learning rates, that is 0.001. So yeah, that's it. That is what I wanted to share, that this is the neural network implementation from scratch. You can see from this repository. Yeah, thank you.